Hello friends, welcome to our YouTube channel Electrical Exclusive. In this class, we shall try to solve top 10 electrical questions for diploma interviews. In this question, it is given we have two loads. This is RA, this is RB. These two loads are connected in parallel to each other across a voltage of 110 volt DC. RA draws 0.8 ampere current, whereas RB draws 0.9 ampere current. Here we have to calculate the value of current when these two loads are connected in series across a 220 volt supply. RA is equal to voltage, that is 110 volt, divided by the current drawn, that is 0.8 ampere, which is equal to 137.5 ohm. Still we have to find the voltage drop across this resistor and this resistor. Voltage drop across first one is V1 and voltage drop across the second resistor is V2. We have to find the values of V1 and V2. So V1 is equal to current drawn, that is 0.847 amp. The resistance, that is 137.5, which is equal to 116.5 volt. Again, V2 is equal to the resistance of the second resistor, that is 122.2, which is equal to 103.5 volt. In this question we have two loads. This is a load and this is the second load. Let's say this is R1 and this is R2. This load is rated 250 volt 100 watt and this one is rated 200 volt 100 watt. We have to find the total current drawn when these two loads are connected in series across a 250 volt supply. So first we have to calculate the value of R1 and R2. For the first load, power P1 is equal to V1 square divided by R1. That implies R1 is equal to V1 square divided by P1, which is equal to V1 is given as 250 volt, 250 square divided by P1. P1 for the first load is 100 watt. That is equal to 625 ohm. So we found R1 is 625 ohm. So for the second load, power P2 is equal to voltage V2 square divided by resistance R2, which implies resistance R2 is equal to voltage V2 square divided by power P2, which is equal to V2 is given as 200 volt and power P2 is 100 watt. Which is equal to 400 ohm. So R2 we calculated 400 ohm. This is the R1 and this is R2. These two loads to be connected across a 250 volt DC supply. R1 is 625 ohm whereas R2 is 400 ohm, and we need to calculate what is the value of current drawn. I is equal to the applied voltage, that is 250 volt, divided by the total resistance of the circuit, that is 625 in series with 400 ohm, which is equal to 0.244 amp. Voltage drops across each individual resistor, suppose V1 and V2, then V1 is equal to current through the resistor, that is 0.244 amp into the resistance 625, which is equal to 152.4 volt. V2, the voltage drop across the second resistor. The current through the second resistor is the same current, that is 0.244 amp into the resistance of the second resistor, that is 400 ohm, which is equal to 97.6 volt. We have a load. Suppose this is our load. It has the rating 200 volt, 500 watt. What is the additional resistance needed to be connected in series with this load when the supply voltage is 240 volt? Well, the maximum value of safe current for this load can be calculated from this equation. P is equal to VI, which implies current I is equal to P by V. P is given as 500 watt and voltage V is 200 volt, which is equal to 2.5 amp. This load is manufactured for a 200 volt supply. If we supply that load with a 240 volt supply, then the excessive supplied voltage will be 240 volt minus 200 volt, which is equal to 40 volt. This is the voltage that needs to be dropped across the additional resistance. Additional resistance, let's say R star, is equal to voltage, that is 40 volt, divided by the current, that is 2.5 amps, which is equal to 16 ohm. This one is R1 and this is R2. When these two resistors are connected in series, the equivalent resistance becomes 18 ohm. If they are connected in parallel, the equivalent resistance becomes 4 ohm. What is R1 and what is R2? So in series, the equivalent resistance is 18 ohm, that is R1 plus R2 is equal to 18 ohm. When the resistors are connected in parallel, that is R1 into R2 divided by R1 plus R2 is equal to, if we put this first equation in the second equation, then our equation becomes R1 R2 divided by, instead of R1 plus R2 we shall replace 18, is equal to 4, which implies R1 R2 is equal to 72. Till now we have derived three equations. This is first equation, this is the second equation, and by putting the first equation in the second equation we found another equation, that is, so now R1 minus R2 is equal to square root of R1 plus R2 whole square minus 4 R1 R2, that is equal to 18 square minus 4 into R1 R2, that is 72. Whole square root, that is equal to plus minus 6. Let me write this equation again. R1 minus R2 we just derived, plus minus 6 and R1 plus R2 is given as 18. From these two equations you can find one resistor has resistance 12 ohm and another one 6 ohm. We have a load. Its rating is 250 volt 100 watt. This resistor is connected in parallel across a 250 volt supply. And it is given the total power drawn is 1100 watt. And we have to calculate the power drawn by this resistance. Suppose this is resistance R. According to this rating, this load will draw 100 watt and the total power drawn is 1100 watt. That's why power consumed by resistance R is equal to 1100 minus 100 is equal to 1000 watt. This 1000 watt will be drawn by the resistance. So what is the resistance? We know power P is equal to V square by R. That implies resistance R is equal to V square by P. So voltage across the resistance is 250 volt divided by the power drawn by the resistor, that is 100 watt, which is equal to 62.5 ohm. In this question we have three resistors. These three resistors are connected in parallel and we have supplied a voltage V volt. This resistance is 4 ohm, this resistance is 12 ohm and this resistance is 6 ohm. Total current drawn is 12 ampere. We have to find the power consumed by this circuit. Here three resistors are connected in parallel. So 1 by equivalent resistance R equivalent is equal to 1 by 4 plus 1 by 12 plus 1 by 6, which implies 1 by R equivalent is equal to 6 by 12, which implies R equivalent is equal to 12 by 6, that is equal to 2 ohm. So we found R equivalent is equal to 2 ohm. So let's find the power consumed. P is equal to I square R, that is equal to I is given as 12 amps, 12 square into resistance R. We have just calculated R equivalent is 2 ohm, that is equal to this is the given network. This resistance is 4 ohm, this is 8 ohm, this resistance is 4 ohm, this is 6 ohm and this is 24 ohm. This electrical network concedes both series and parallel connections in it. So we have to simplify the network. Suppose this point is A, this point is B, this point is C and this point is D. The total resistance RAB, likewise this whole resistance is RCD. So let's find RAB. 1 by RAB is equal to 1 by 4 plus 1 by 8 plus 1 by 4. That implies RAB is equal to 1.6 ohm. This resistance is 1.6 ohm. Let's find RCD. 1 by RCD is equal to 1 by 6 plus 1 by 24. Which implies RCD is equal to 4.8 ohm. So this resistance is 4.8 ohm. Now you can see RAB is in series with RCD. We can simplify this network. This is 1.6 ohm and this resistance is 4.8 ohm. The equivalent resistance R equivalent is equal to RAB plus RCD, that is equal to 1.6 plus 4.8, which is equal to 6.4 ohm. This is a 20 ohm resistor, this is a 30 ohm resistor, and this resistor has a resistance 10 ohm, and this network is connected to a voltage source of 100 volt. This is point A, this is B, and this is C, and we have to find what is the power delivered. So now we need to calculate what is the equivalent resistance of this circuit. So no doubt the current that is drawn from the supplied voltage source will be divided at the point A. This current passes through both 30 ohm and 10 ohm resistor. So I can say 30 ohm resistor is in series with 10 ohm resistor, and this whole resistance is parallel with the 20 ohm resistor. R equivalent is equal to 30 ohm in series with 10 ohm, 30 ohm plus 10 ohm. This whole resistance is in parallel with 20 ohm resistor. That is equal to 40 ohm resistor is in parallel with 20 ohm resistor, which is equal to 40 ohm into 20 ohm divided by 40 ohm plus 20 ohm, that is equal to 13.3 ohm. So we found R equivalent is equal to 13.3 ohm. So power drawn, that is P is equal to V square by R equivalent, which is equal to V is given as 100 volt by R equivalent, that is 13.3 ohm, which is equal to 751.9 watt. Friends, yet this question is not completed. According to the second part of the question, this 100 voltage source is applied across 30 ohm resistor. Here we have to apply the 100 voltage source. Then what is the power drawn in this case? The current that is drawn from the supply will be divided at this point. So no doubt this current will be same through 20 ohm resistor as well as the 10 ohm resistor. That's why 20 ohm resistor is in series with 10 ohm resistor, and this whole resistance is parallel to 30 ohm resistor. So R equivalent is equal to 20 ohm in series with 10 ohm. This whole resistance is in parallel with 30 ohm, which is equal to 30 ohm in parallel with 30 ohm. That is equal to 30 into 30 divided by 30 plus 30, 15 ohm. Well, we found R equivalent is equal to 15 ohm. So the power drawn will be P is equal to B square by R, the same formula that we have applied in the previous case, is equal to voltage, that is 100 volt, resistance, this is equivalent resistance that we found 15 ohm, which is equal to 666.6 watt. We have two emitters. This is emitter A and this is emitter B. These two emitters are connected in series. 2A, 20 ampere current source. So no doubt this current is 20 amperes and it is given 0.2 volt is dropped across emitter A. Likewise 0.3 volt dropped across emitter B. And according to the question, if these two emitters are connected in parallel to the same current source, that is 20 ampere source, then how this 20 ampere gets divided? The resistance of emitter A, that is RA, is equal to the voltage across emitter A, that is 0.2 volt, divided by the current that is passing through the emitter A, which is equal to 0.01 ohm. And in the same way 0.3 volt is dropped across emitter B. That's why the resistance of emitter B, that is RB, is equal to 0.3 volt divided by the current through the emitter B, that is 20 amps, which is equal to 0.015 ohm. So let's reconnect the circuit. Well, this is emitter A and this is emitter B, and we have already found emitter A has a resistance RA is equal to 0.01 ohm and RB is equal to 0.015 ohm, and these two emitters are connected in parallel to each other to a current source of magnitude 20 ampere. What is the current through emitter A? Let's say that is IA, and what is IB? This current source is I. By using current divider rule, IA is equal to the total current, that is 20 ampere, into other resistance, that is 0.015 ohm, divided by the sum of the two resistances that are connected in parallel. IA is equal to total current 20 ampere into the other resistance, that is 0.015 ohm, divided by the sum of these two resistances, that is 0.01 plus 0.015, which is equal to 12 amps. Again, to find the current IB is equal to the total current, that is 20 amps, into the other resistance. This time RA is the other resistance whose value is 0.01 ohm, which is equal to 8 ampere. What is the value of equivalent resistance?